Python since probably before I started using it, which heaven knows is a considerable time ago now. So without further ado, ladies, Raymond Hettinger is going to tell us what's awesome about Python. Raymond.
Thank you, Steve. That's awesome. Oh my goodness, there's a lot of you. All right, how many of you enjoyed the lightning talks this morning? Were they awesome? How was Pycon in general so far? Was it awesome? Yeah. You should thank Jesse Noller and all of the volunteers for that. They're doing an amazing job. Awesome. But what's it all about? It's about a language that we claim to be awesome. Let's go ahead and, how do you switch between me and slides? What's that?
Just ask the
all right.
They will put slides up.
Slides! Ah, there we go. Now you can't see like little bits of sour cream that my baby just put there a few minutes ago. Okay, there's my Twitter account, Raymond H. I teach Python through Twitter. I don't tweet when I'm at an airport. I teach you about Python 140 characters at a time. So I hope I pick up a few new followers today. I currently have 4,000 people learning Python through Twitter. So it's an interesting exercise. So tell me about an awesome language. What is awesome in Python? Have you heard of an awesome language? Is Python any good? You like it? Okay. Well, I'm going to tell you a little bit about what my role was in building it for a moment. I've been a core developer for about 12 years. I've made a bunch of the built-in functions that you use, several of the standard modules. I built in a number of the language features. But my last year and a half has just been great. I've had a chance to teach a lot of people Python. And I've got a chance to experience what's awesome about it and what's not. I've got a chance to introduce it to executives. And one of the interesting themes is that people have a hard time telling you what is awesome about the language. They always tell you that they like it, but they don't know exactly why. So that is going to be the subject of this talk. Again, what language do you think is awesome? Python. So I've got a room of believers already, so it ought to be an easy sell. So the context for success of Python, what put it on the map? If Keynote had not made it an open source license, you probably would have never heard of Python. It's important for the success of a language to have commercial distributions. We have Active State and InThought and other companies putting commercial distros together. You're not a serious language until you have some commercial support. Zen. Tim Peters' Zen of Python. How many of you read it? You should read it all the time. It will keep you focused as a programmer. Python has Zen. Ruby has Zen. Lots of languages have Zen. C++ does not have Zen. I know, because I was on the C++ standards committee. Are you guys impressed by that? You shouldn't be. I was one of about 20,000 people. My qualifications for joining were saying, I want to join. It was literally designed by a committee, and so individual parts are very good, but they don't necessarily have an underlying Zen that connects them together. Something else that makes Python awesome, this community. C is a wonderful language. It doesn't have the same type of community we've got. All these things are features of a language. Pippi, the Python repository, there's upwards of 30,000 modules that are already made, ready-made solutions for you to download. This is awesome. This is a context for success of the language. And you can't be a great language without a killer app. Ruby's got Ruby on Rails. We've got lots and lots and lots of killer apps. And then thanks to Mark Hammond, we run on Windows. A bunch of you are probably Linux weenies and look down on your Windows brethren, but still most of the computers in the world are running Windows, and it's important that we run there. And then you need to have books on the language. I'm very interested in Go. I have a hard time finding books on Go. But Python has a number of extraordinarily good books to get you started. Any language that has these features has the context for success. Let's take a look at our high-level qualities, though, of Python in general. By the way, why am I going over this with you? Because you guys already know Python, right? But you're often put in a position to defend Python. I heard it was a slow language. I heard it doesn't scale. Isn't Ruby more popular now? Isn't it just a passing fad? How do you convince a management of a company to switch over to Python? So I give some variation of this talk to executives to tell them what it is that makes Python special. And my goal is for you to be able to communicate what makes the language special. So ease of learning. One of the fantastic things is David Beasley teaches a course where at the end of the second day, students are able to write some amazing code. One of his exercises is to go through, oh wow, all I see is just bright lights now. This is interesting. One of his exercises is to take some logs on the web and traverse all of the logs, unzip them, count up all of the hits on web pages and summarize the top 20 hits and rank order them and pretty print the output. That doesn't sound like a terribly difficult task. On the other hand, students who couldn't program before in any language can all do it at the end of the second day. I think this is impressive. Python is a very teachable language. The rapid development cycle is part of what it's famous for. If you were selling Python to somebody, you tell them that is one of its #1 characteristics. I worked at a high-frequency trading company, and speed matters there. Why would we choose Python? The answer is rapid application development. We could see an opportunity in the morning, model a strategy on it, and be trading it in the afternoon. As good of a Java programmer as I ever was, I could never do that kind of turnaround cycle with Java. The readability and beauty is one of the #1 attractors to the language. The way to think about the significance of the readability and beauty, especially if you're communicating it to somebody else, why would they care if the language is beautiful? That's because Python programmers will stop on the way to work and write some code. They will go home after work and write some code, and they will write code on the weekends. I code in C++ as well. I can tell you I never code C++ on the weekends. It's not fun. It's not beautiful. There's a reason that you want a beautiful language. And it's a batteries included language. There's a phenomenal amount that you can do right out of the box. And lastly, one of the things I love are the protocols. Things like the database API. That was well thought out at the beginning, so if you learn the databases one time, you've learned to work with Postgres, you've learned to work with Oracle and MySQL. All of them have the same interface. These are fantastic high-level qualities of the language. Who thinks it's awesome now? A bunch of you. So you dig it. Here's a bit of awesomeness. This is a 5-minute problem. I was teaching a class one time and someone just gave me a quick example. How would you do this in Python? They had a bunch of duplicated images on their hard drive. They were a photographer, and so they had several terabytes of images that had been copied many times. They said, how would I dedupe them? And so this is the complete script. It starts with a dictionary, or hash map. We use OS walk to recursively walk through the directories, open each file, compute a checksum of the file, and use that as a dictionary key to identify all the duplicates, and then pretty print the list of duplicates at the end. One of the great things about this little problem that it highlighted for me was I was able to do it in class as a live demo in under 5 minutes and run it perfectly. And it's not because I've had a lot of practice at Python. I can teach other people to do that after a couple days. Who thinks it's awesome that you can write a program like this in 5 minutes? This is a killer feature of the language. It's productivity and it's beauty and brevity. Do you guys think this is a winning argument for Python? This one screen? Oh, it does. I actually run the code on my slides before I load it in. It does. Unless I went in and, while colorizing it, put in introduced a typo after the fact. So, I think this is an awesome example of Python. There's a problem with it, though. I could present you another slide with about the same code in Perl and about the same code in Ruby with about the same brevity. And so what I would have convinced you is all scripting languages are basically the same with slightly different syntax. Do you think Python's awesome now? No. I hear it a lot, especially from executives, people deciding whether or not to use Python. It's just another scripting language, as if the choice between, we will keep one compiled language, we'll have one scripting language, and any scripting language will do. I ask you, are they all the same? No. So what is it that makes your language special? I would say back in the year 2000, It was true. All scripting languages were the same. But we've grown since then, and we have things that make it great, things you don't get anywhere else. And so I'd like to put these answers in your quiver of arrows so you know why your language is special and what makes it awesome. We've got indentation. This is the way you write your pseudocode. It contributes to Python's clean, beautiful appearance. And it was a big, bold move. When Quito did it, nobody was using white space for control flow. So it was an audacious move. And it was proven to be a winning move. Even now, there are people who come to Python and initially react to the white space as if it were not a good idea. Why do you need it? I often give these examples. These are some C examples. The first one prints good morning exactly one time. The cause is the trailing semicolon. Do I blame the semicolon? No, it's not the semicolon's fault. The semicolon, it's its job to close the for loop. What I blame is that tab right there. The tab before the print is the big lie. It's the thing that promises that the print will be inside the for loop. It's the thing that is not actually doing anything. And so the indentation has created an optical illusion. Likewise, in the second set of code, I often ask people, under what circumstances do these various prints work? The important fact is that without the curly braces, it's hard to tell how these match up. The else binds with the most recent if. This is misindented code. It's essential when you're reviewing C to actually run it through a beautifier to re-indent it. Even if your editor indents for you, someone else will mangle it at some point. And so the problem is the visual appearance of the code lies. Does Python ever lie to you with its visual appearance? Never. It's a winning feature of the language. These type of errors can't happen in Python. Good morning will happen 10 times for us, and if we unindent it, it will happen exactly once. Winning feature of the language. One of my favorite features of the language is the iterator protocol. If you pick up the book Design Patterns, you'll learn the iterator protocol can be implemented just about anywhere. There's a design pattern for implementing it in Java and in C++. We've got it too. What's different for us? The answer is we don't have to go through all the usual method calls for the iterator protocol. It's built into the for loop, and so it makes it effortless to use. That makes it effortless to consume iterators. How do you make iterators easily? Answer, we added one additional word, yield. That was Kemping's work, and it profoundly improved Python. It made it possible to create iterators effortlessly. So what we did different than other languages is swallow the red pill. We use iterators everywhere. Python is just a big box of Legos where all the pieces fit together perfectly. It's really nice. When I wrote sorted, I wasn't thinking about sets. When I wrote sets, I wasn't thinking about strings. But those parts fit perfectly together. That is actually a complete Python script that takes the letters of abracadabra, eliminates the duplicate, and sorts. It is beautiful functional style programming, and Python supports it well. Likewise, set of open file and sorted will open a file, loop over all the lines, eliminate the duplicates. The equivalent in bash is to run through sort and unique. Why did I put the bash script up? The answer is I would like to show that iterators in Python are about as powerful as the pipes and filters are in Unix. It's a big pile of composable, reusable tools. I think it's a winning feature. When you talked about why Python is great, these are compelling arguments. And then also when I'm teaching Python, I like to give this last example. This takes a list of tuples, unpacks the tuples, computes the shares times price, adding them up, giving a cost basis of a portfolio. What is the equivalent in SQL? It's on the next line. Do Python expressions have the same level of expressivity as SQL? I think so. This is a winning feature. And when you start to compare it back to languages where people spend a lot of time with for I equals 0, I less than n, I plus plus, they can't compete with this level of expressiveness. Are you digging Python now? Yeah. Yeah. All right, list comprehensions. This is my favorite thing to teach. It is arguably one of the most popular features in the language. They're beautiful and expressive. They were designed based on the set builder notation in mathematics. They profoundly improve the expressiveness of Python. I particularly like this last example because it corresponds exactly to the way that you would write this equation in mathematics. But the first line shows that it's not just a mathematical concept, which raises the question, how much stuff should you put on one line? Python is a language where initially we try and tell people don't put too much on one line. But list comprehensions tend to be a little bit wide. Is that a problem? No, it's actually a profound thing because it allows you to think of this not as the individual steps of setting up a for loop and building up a list. It allows you to think of it as a higher level thought of I'm summing the cubes, or I am lowering all the lines where the line contains info. My thought is if it can be expressed in a single English sentence, it belongs in a single statement in a language. And Python allows you to do it. How many of you just totally dig list comprehensions? It was a big win. Generators. This was Keynote. This was a masterpiece. We stole it from Icon. Icon was not as popular of a language as it should be, so generators didn't become popular. Keynote put generators into Python, and Python is popular, so lots of other languages are getting them now. You can expect that Python is got features that are demonstrating the value of those features, and you can expect many languages will have these features in the future. It's actually a trend-setting language in some regard. It is a big deal. The generators give the functions the magic ability to freeze themselves in the middle of execution and resume later. And that's something that we couldn't do before. It enables us to implement coroutines and more importantly, lets us implement iterators almost effortlessly. People are amazed when you write iterators using classes, the way you do in design patterns, and then transform it to the iterator style, how it condenses sometimes the code by a factor of 10. It makes it clean and readable and beautiful. How many of you dig generators? That's cool, because this is advanced technology. This is the technology of the third millennium, not that second millennium stuff back when the year 2000 where all scripting languages are the same. It's something we've got, other people don't have. Okay, so there's a quick example using generators. It's very few lines of code on this slide. If you try it any other way using classes, you'll be working really hard. This is something that makes Python clean and beautiful. So, I like to call list comprehensions chocolate and generator expressions peanut butter. What do you do with peanut butter and chocolate? Stick them together and make Reese's or Kit Kat bars. So my bright idea, this was me, generator expressions, was to combine list comprehensions and generators to make generator expressions. Once that idea was out of the bag, it was a very natural expansion to make set comprehensions and dict comprehensions. Pretty much once you've learned list comps, the generator expressions come effortlessly. Why are the generator expressions a big deal? They give you the beautiful expressivity of list comprehensions, but the other thing they do for you is give you a lot of speed. It runs in a tiny amount of memory. It gives you scalability. When people complain about Python's speed, they're often complaining about if it has a big memory footprint, nothing is ever in cache when your program runs. But if you build your program around iterators, everything is small. With a small memory footprint, it's all in cache and it speeds up markedly. This is one of the easiest ways to make Python programs go fast. It's something we've got that other people don't have. Who thinks it's awesome? Okay, here's a couple examples of generator expression, a set comprehension, and a dictionary comprehension. They're all simple and readable. I particularly like this last one. It says, I read it left to right as the curly braces say I want to make a dictionary, where the key is a file name and where the value is the file size. And the source of the files is the current directory. It reads left to right, essentially, like you would say an English sentence. It reads like a spec. I want you to make a dictionary where the key is a file name and the value is the file name, and take all the file names from the current directory. It reads like a spec. This is clean, beautiful Python and a winning feature. Generators got a problem, though. They are a boring date. I had a date one time, went and the person talked and they were very eloquent. But at the end of the day, I hadn't spoken. They couldn't tell you my name. Was that any fun? Generators are like that. All they do is give you data. You can't talk to them. This is a solvable problem. We have generators that accept inputs now, two-way generators. This is advanced technology. Generators in other languages didn't do this before, so it is unique to Python. And it makes it possible to implement wonderful things like coroutines and to tame Twisted's inline deferred. And I think it makes Twisted profoundly more beautiful when you use the inline deferreds. How many of you are Twisted people? How many of you used inline deferreds? How many of you think they completely rock? They improve your programs quite a bit and make them readable, far more than the usual callback style. So we now have two-way generators, ones that you can talk to and send data in as well as get them out. This was a big step forward. So this is a two-way generator example, and it shows a twisted inline deferred. And this little example, I won't go so much into what it's doing. It is managing a session with a client doing an authentication, a database query, and yielding some formatted back. At each stage, it needs to block a little bit while some activity happens. We write it just like sequential code, but everywhere it would have blocked, we introduced a yield. The yield will hand control back over to the event loop, let it handle other actions until the data becomes available, and then the code will pick up where it left off. If you don't appreciate this code, you should try and write it the old way, writing 5 separate functions as callbacks and error handlers and daisy chaining them together. It's like writing a finite state machine. It's not fun. This is simple and beautiful, and I think it makes Twisted a lot better. Who's digging Python now? All right. Decorators. They're expressive and easy on the eyes, and just didn't seem like a good idea. People ask for decorators. Oh, please give me a decorator. But when they ask, it was clear anything that you could do with a decorator, you could have done without a decorator. It didn't add any new functionality to Python. We could always do the things we did with decorators. So the first few requests for decorators were turned down. Guido just said no. Why? Because we don't arbitrarily in Python introduce unnecessary syntax. People ask again and again, and so Guido has a way of getting rid of you when you ask him too many times. He says, if all of you can agree on a syntax, I'll consider it. Something happened that never happened before. The entire community agreed on a syntax. We gave it to Guido, and he says, all right, you shall have decorators, but not the syntax you asked for. You can't make this stuff up. That was a true story. And boy, had we been wrong about them. Decorators turned out to be a profound improvement to the language. I don't know how many of you have ever subclassed from a simple HTTP server before, but it's not fun. Here's the new way to write it. There are a whole bunch of lightweight frameworks that use exactly this style. The smallest of them is IDI. Bigger ones include Flask and Cherry Pie. All of them use this style where you use a decorator, like a get, to associate what is called a route or a path with a function. This is a piece of code that I have deployed on many machines in the cloud, and when I turn it on, it runs a web server for me, and it supports, I can ask for the free space on one of my remote machines. It runs a sub-process, finds the amount of free space, and sends it back to me on a web page. If I request a resource that is not listed, it'll give me a 404. If there's some internal error, it'll take care of generating the 501 for me. To add a new service to this script is typically about 3 lines. I put the at for the route, the def to define a function, and then a body of a function. It's that easy. This is a profound improvement over the old way of doing things. It's why decorators are a winning feature, and it's something Python's got that other languages don't have. Who's digging Python now? All right. This is the technology of the 3rd millennium. We didn't have any of this stuff in the year 2000. At that point, we really were equivalent to Perl and equivalent to Ruby. These things are all special. This is why you should pick Python over one of those other languages. The with statement, context managers. When I first saw them, I thought it was a little bit arcane, and then I had this profound realization. If you want to switch back to me, I'm going to try and oversell them. Who's ever doing the slides? Picture of me on the screen, so I can teach by shadow puppets. Okay, no pictures of me. I'm going to oversell the with statement for a moment. What was the most important invention in the history of computer languages? It was the subroutine, where you have 3 sets of statements, and the one in the middle gets repeated somewhere else, and you want to factor them out. You have procedure A, B, and C, and then you have P, B, and Q. The B's get factored out into the subroutine. In terms of a food analogy, if we have a white bread with peanut butter on it, and later we have wheat bread with peanut butter on it, we factored out the peanut butter. Everybody knows the subroutine is a big deal. Every language has it. What happens, though, if it's the bread that remains the same? All the things that you can put on white bread. What if you want to factor out the bread and not the body? I can put tuna on white bread. I can put peanut butter on white bread. It's the body that's different. What is the complement of the subroutine? I'm going to suggest that the subroutine is the part in the middle. Oh, I can't believe I just did that on a on a recorded video. And the with statement is the part on the outside. That'll be a famous screenshot. I'll be hearing from the diversity police. Okay, you can switch back now. Slides are safe. Okay. So I'm suggesting that possibly context managers may end up being almost as important as the subroutine itself. We've only scratched the surface with them. We use some things like to factor out locks. So that one has been around for a little while. This is one that I just checked in a couple days ago, how to ignore an exception. And this is one that's been in for a little while in the decimal module to set up a temporary context. The with statement sets up a temporary context for you and tears it down. It factors out the bread. It is a tool for factoring. It is a tool for making your code clean and beautiful. And it's something we've got that other people don't have. Who's digging Python now? You might have one other objection. BASIC has a with statement. There's with statements in lots of languages. They don't do the same thing. They all do something very shallow. They save you from repeated dotted lookups. They don't do our setup and teardown. So just because it's the same name, don't think it's the same thing. The with statement is a very big deal. I would encourage you guys to go out and take this tip of the iceberg and drill deeper. You can probably do profound things with the with statement. The best uses of it have not been discovered yet. I expect that if you guys make good use of it, it will be copied into other languages, and all future languages have it. You can be part of discovering something almost as profound as the invention of the subroutine itself. I think these are a very big deal. Something we've got, other people don't. I want them to have it too. Go prove to the world that they're awesome. Fair enough? All right. Abstract base classes. I'd like to say every great idea that comes along, I just embrace it. I fought these. Guido went to a program in Java for about 6 months, and he came back with abstract base classes, and I did not want them. I felt like it was introducing a Java-esque feature into Python. I've come to embrace them over time. We used to talk about sequences and mappings, but everyone meant something different. Now they have a precise meaning. It is very well defined what a sequence is and a mapping is. Even if you never use abstract base classes, you're going to get the benefit of them. There's a reason that tuples now have index and count, and we thought they never would, because it's part of the sequence API. It unifies and beautifies the language even if you never use them. The fact that we define these things is important. And then something interesting came out. I'll jump to the bottom part of the slide here. That was the mixing capability. We had that before with the user dict, but now you can have it with many things. The advantage of mixing capabilities, it makes it very easy to write your own dictionaries and sets and to customize Python. This is an amazing tool for code reuse. It lets you factor out reusable parts of your classes and use them in many places. But then there's the weird part. How many of you have heard of duck typing? Who thinks it's awesome? In order to take advantage of that, there's one discipline. Just never use the test is instance. Don't do type checks. Everywhere you did type checks, it precluded you from the ability to do duck typing, and you guys just told me that it was awesome. Anybody puts in type checks is defeating duck typing. Your first 6 months of Python, if they were like me, I put type checks everywhere. My next 6 months, we're taking them all back out. The maturing of a Python programmer is to not use his instance anywhere. So what did Guido do with it? He says, you can use his instance texting again and still get duck typing. How? We get the ability to lie to is instance. I thought this was incredibly weird, but there are some great use cases for it. Pretty much people can start using is instance again, doing their checks, and then if we want to duck type and inject something, a class that was previously unseen, we can lie about our capabilities. So the old duck typing said, if it looks like a duck, walks like a duck, and quacks like a duck, it's a duck. The new duck typing says, well, it said it was a duck, and that's good enough for me. Maybe it says it's a Django pony. So this is something else that is making Python awesome. The abstract base classes give us tight definitions. They also give us another tool for reusing and organizing our code, and they now allow us to reintroduce is instance checking. This was all Guido, another bit of awesomeness. He does not run out of great ideas. Who thinks Python's awesome now? These are things we've got other people don't have. Here's an example of an abstract base class, or use of an abstract base class. This is inheriting from a collection set. All you're required to do is implement dunder iter, dunder contains, and dunder len. What do you get in return? This is the complete code for implementing a set based on list. It's fantastic. You don't see it in there because we've inherited it. This can do a subset test, a superset test, set equality. It provides a disjoint. It provides union. It provides intersection. It provides a difference, and it provides symmetric difference. Is that a lot of code reuse? I think so. This saved you from writing 100 lines of code to get to implement a set. How much testing is required to get this code up and running? Very little, because you're inheriting from a class that from an abstract base class that's already been heavily tested. Things like this improve your productivity monumentally. I think abstract basis classes are a big deal. Who digs them now? So the summary of the winning language features, things that we have that other people don't have, compelling reasons to use Python over another scripting language, are the indentation, the iterator protocol. Again, other languages you can do the iterator protocol. What's different for us is we swallow the red pill. Everything that can be an iterator is, everything that consume an iterator does, all the parts fit together perfectly. There's Kaping's generators that were awesome. List comprehensions, and generators that you can have a full conversation with. You can send data into them and pick a data back out. Decorators were something that we thought wasn't a good idea, and we were wrong. They were a profoundly good idea. They are a fantastic tool for code reuse, and the with statement, where I've suggested to you, might be as important as the invention of the subroutine itself. And abstract base class is another tool for code reusability. How many of you think Python is awesome? I normally don't like people to take my slide decks and give my presentations and go up and be me later. Please take this presentation and go be me. Take it back to management. People say, should we decide on Python or Ruby? Show them this deck. There's something we've got, they don't. Use it as a selling point, and now you actually have the ability to answer, what is it that makes your language awesome? We'll switch back to slides just one more because, as Jesse said, there's one more thing. Somebody said it before Jesse, but I like the way Jesse said it better. What have we got? We've got talent. We have the old superstars. Now, there's a lot of stars in the room. These are the superstars. The superstars are the people who have just blown me away in terms of they're some of the smartest people I've ever met. The names at the top are all the one-namers like Madonna and Sting. There's Guido and Uncle Timmy and Barry and F-Bot and Kaping and Glyph. People just know who they are just from that part. But there's some other superstars where you have to spell their whole name. Frank Wierzbicki with Jython, Armin, who is probably the smartest person I have ever met, Alex Martelli, who has an encyclopedic knowledge. These are the people who took me from being a good programmer to a great programmer. They're superstars, and it's something the language has. If you want to know why the language is good, it's because of these people. There's a long list of the Python committers here. At some point, I recommend you take a look. Don't just use the language, find out who these people are. The superstars made this language great. But what's cool is now we have young rising superstars, people who are just blowing me away, who are young and are accomplishing more at early ages than I could have ever imagined. They will beat the socks off of everybody at the top of the page because they're already doing as much at an early age. There's more than are listed here, but Benjamin Peterson started as a Python release manager at 15 years old. He's amazing. Jessica McKellar, who was supposed to speak to you this morning and couldn't, is a rising star. She is a phenomenal talent and a community leader. Alex Gaynor, who is also one of the smartest people you ever met, will ever meet, an important contributor to Django and to PyPy, and now back to CPython itself, and he's becoming a community leader himself. These are your stars. This is something that we have that other people don't. Other languages have 1 or 2 stars. We have a lot of them. And here's some of your superstars. If your name is not on the list, I think you're a star too. These are the ones that have just blown me away as I've gone through. That's what Python's got that other languages don't have. So thank you very much for listening to the talk. Please use this slide deck and go teach people Python. It's already been uploaded. Tell them why the language is great, and have a wonderful rest of your PyCon. Thank you very much.
question. So we do have a couple of minutes if there are questions for Raymond. We do have a microphone up front here. Just come up to the mic. And
so I can be called out?
Okay, so the first question comes from Alex Martelli.
Miranda.
Danger. Yes, sir.
You had a slight mistake there, and the mistake's name is Miranda. It's got nothing to do with your rights when arrested. It's got everything to do with the first language to use white space semantically. Haskell inherited it from Miranda.
This is not the first time I've been schooled by Alex Martelli. There was a predecessor for indentation. Guido was not the maverick that we think of. He stole it from Miranda.
This is your first Miranda warning. So
there you go. $5. Yes, sir.
Hi. So I love Python. I've been evangelizing it for 15 years, but I have a question that sometimes people ask me that I don't know a good answer to. Why is len a function and not a method?
Why is length a function and not a method? Well, if we were Ruby, we would have made everything a method. And that was a reasonable approach to a problem. Lots and lots of languages had a length function, and people are used to it, and it's very readable, and we're translating code from somewhere else. When you think about problems, you tend to think of it as a function and not a method. Underneath the hood, we use a method to unify the language. So I believe that Guido chose this for readability. It follows people's thinking conventions, and so Python abandoned the rigidity of saying everything must be a method and realized that people sometimes think a little bit differently. So the short answer to your question is practicality beats purity. Fair enough.
It occurs to me that some of the winning features you named, like decorators and the with statement, are the sorts of things that make Python actually non-orthogonal. You'd use higher order functions, for example, in a scheme. I think that's because they make common patterns available lexically, just as you're reading the code.
Yes.
Whereas they'd be hidden behind documentation otherwise. Can you think of some other patterns that you might want to surface lexically as well?
Not off the top of my head.
Something to think about.
But I can think of something that I forgot to mention that additionally makes Python awesome. PyPy. PyPy is going to be, I believe in the future, the primary way that you interact with Python, and it's going to give us our last bit of awesomeness. It's going to give us our speed while we get to keep the beauty. So it's a very big deal. Apologize for not answering your question straight out. I just think that if we'd already had a great idea and it was mature and the right thing to do, it would already be done. So think up new ones that haven't been done is a harder to answer question. Yes, sir.
Well, in that vein, there are ideas that people have and things that other languages do that Python doesn't that might be good ideas.
Yes.
So what is the best idea to get things rolling on getting those into Python, and what should people do when they get told no?
Ooh, good question. If you want to take your favorite feature from another language and inject it in Python and you get told no, what do you do? Perhaps the no is a good idea. Python is beautiful for a reason, and part of the reason is the things we don't put in. Right now there's a discussion of whether or not to put enums in the language. Enums are very popular in other languages and necessary in those languages and make up for some of their deficiency. I'm of the belief of I've programmed Python for a very long time, every day, and have never needed an enum. That said, a fairly beautiful proposal is on the table, so it has some chance of being in. But for the most part, the language we better off with not sticking more things in. It is already a very beautiful, vibrant language. What it needs more than language features is better and more modern libraries. Our URL libraries, for instance, they really show their age. We're hoping to put requests in Python 3.4, for example, to modernize it. Put your effort in the libraries. Don't join Python and try and your first proposal is to muck up the language and I'm going to take dictionaries and twist them into knots. We've already got nice dictionaries. Go out there and build a Python project. Join an existing Python project and make it awesome. But don't take a mature, beautiful language. Join the developer community and say, hey, my first contribution is going to be to inject a whole bunch of features from Java. Because Java has things that it's really good at that fit its paradigm that don't necessarily make sense in Python. So I would say the number one thing you could do to improve Python is show restraint. That means don't join the Python ideas list. There's no restraint on that list. I'm bagging on them a little bit. It's actually a great place to play and discuss wild ideas, but when they get a little bit too serious, like, hey, we're going to take every random idea we can think of and inject it to the language, it is heart-wrenching to watch some of those threads because you fear that some of them might actually happen. I would just say, show some restraint and try to not destroy the thing that is beautiful before your eyes, because it would be easy to mangle it. Yes, sir?
So I totally agree with you that Python is awesome. I have the same experience as you in that I teach programmers Python, and I see some places that are not awesome.
Yes.
And it seems to me that improving the language, we can make it more awesome by adding cool new stuff or by fixing the stuff that sucks. And I just wonder if you would quickly identify for us your perspective on what sucks.
What sucks? I actually wanted to give a talk on what sucks, but it's not appropriate for a keynote where you're supposed to cheerlead and go, whoo, Python's the best. Yes, there's some things that suck. I don't like if dunder name equal dunder main. I think it's one of the ugliest pieces of code I've ever seen. If it were up to me, special or magic methods wouldn't be called special or magic. They are just regular methods that happen to have a shortcut for calling them. Dunder add is a normal method, but there's a plus operator that happens to call it for you. So the naming convention just says there's a shortcut. Every time we call them magic, we suggest that they are actually more magical than they actually are. They're quite normal in that regard. One thing that I have wanted over and over again is constants in Python. Fortunately, I didn't push too hard to put them in because PyPy may make them entirely unnecessary. It figures out what a constant is. A constant is a variable that just didn't happen to change. And PyPy is good at ascertaining those things. I am at a loss right now of a couple other things that have irritated the heck out of me, but I imagine you've got a couple on your mind. Do you have a couple to volunteer?
Nothing that irritates me. I love programming in Python because of the beauty of the language and the community, and I really appreciate you putting the names up of some of the stars for us to thank. Would you share some of your thoughts on a project like GitTip, which is a way that we can thank people in the community?
I don't know about that. That may be your opportunity to say it at some point.
To Chad Whitaker, who's...
I've got a question for you guys to wrap it all up. How many of you have tried Python 3? That's great. How many of you use it commercially? So it's still a little bit young. How many of you intend to be using it commercially? How many of you tried PyPy? It's wonderful for me to be able to ask this question because you know as core developers we don't actually know our download statistics because you can pull down PyPy or in so many different ways. We really don't know how many people use it, so I appreciate that little survey. It looks like everybody has tried Python 3. Now you need to start using it commercially. Thank you very much. I'll turn it back to Superstar Steve Folin.
Thank you, Raymond.
Stay on stage and we'll get Matthew.
So I hope we all feel better about being Python programmers now. So I don't know whether any of you know, Raymond has actually been doing his little bit to maintain and develop the international Python community. And we have his wife Rachel here with the latest member of the Hettinger family, Matthew, wearing the cutest little Python shirt you have ever seen in your life. Raymond, thank you very much indeed.
The next generation of Python programmers. Hip hip, hooray! Hip hip, hooray! Is he happy?
Thanks very much. We'll take a break and talks will resume after that break. Thank you again.